The VXLAN Gateways, Purpose and Function Module. By the end of this module, you should be able to describe the purpose and function of VXLAN gateways. A virtual tunnel endpoint, or VTEP, in a virtual extensible LAN or VXLAN network is a Layer 2 or LL2 gateway. Layer 2 gateways bridge Ethernet frames within a VLAN or VNI or virtual network identifier and do not forward traffic between different broadcast domains. A Layer 2 gateway encapsulates Layer 2 frames in VXLAN packets and performs a Layer 3 or L3 forwarding operation on the Layer 3 IP fabric, and decapsulates a VXLAN encapsulated packet and performs a Layer 2 forwarding operation bridging to a host or virtual host device. A Layer 3 gateway has different functions. A Layer 3 gateway functions as a bridge between VNIs and enables traffic from one VNI to be forwarded to a different VNI, and changes the source MAC address of the underlying Ethernet frame and places the local integrated routing and bridging or IRB interface virtual MAC address, gateway MAC, in its place prior to forwarding the Ethernet frame in the new VNI.
A device that has VTEP functions enabled is a Layer 2 gateway, as it has the capability to perform VXLAN encapsulation and decapsulation functions. It is the endpoint of a VXLAN tunnel. A VXLAN Layer 2 gateway is often just referred to as a VTEP. A VTEP, or Layer 2 gateway, accepts servers that are directly connected to its physical interfaces to communicate across a Layer 3 fabric or network with devices that are in the same broadcast domain as the original source. This is what is often referred to as a Layer 2 stretch, or stretching a Layer 2 domain across a Layer 3 domain. Arrives at a VTEP from a virtual machine or VM or host. The entire packet is encapsulated in a VXLAN packet. The original IP address and MAC address are preserved within the encapsulated packet. The encapsulated packet is forwarded across the IP fabric, where the outer MAC address is modified with each hop, which is the standard IP forwarding process. When the IP packet arrives at the destination gateway, which is the remote VTEP, the VTEP identifies the destination address as a local address and removes the outer Layer 3 header to process the packet. Once the outer header is removed, the inner VXLAN header is identified and processed according to the information within that header. Once the VXLAN header information is processed, the locally connected broadcast domain is identified. The outband interface is identified based on the VNI tag in the VXLAN header and local switching table, and the original packet is forwarded towards the destination device based on the switching table information. During this process, the IP addresses of the original packet are not examined. A more detailed examination of the process displays the information in the packets as they transit the VXLAN domain. A Layer 2 gateway, or VTEP, must be able to perform the encapsulation and decapsulation processes for VXLAN packets. Transit devices within the network are not exposed to the VXLAN header information, and therefore are not required to have any special processing capabilities. Only the VXLAN gateways must have VXLAN processing capabilities.
The VXLAN Layer 3 gateway processing sequence is explained here. The Layer 2 frame arrives at VTEP R3 from user 1 with a destination MAC address of the default gateway, the source MAC and IP of user 1, and a remote destination IP of server 1. The VTEP R3 looks at the destination MAC and selects the VTEP R2 as the endpoint to reach the gateway. The unmodified Layer 2 frame is encapsulated in a VXLAN packet with a VNI of 5100 and the outer header having a destination IP of VTEP R2. This is the first tunnel. The packet transits IP fabric as normal, IP forwarding. The IP packet arrives at VTEP R2, the Layer 2 Layer 3 gateway. The outer destination IP matches the VTEP address. The L2 gateway terminates the tunnel, and the destination MAC matches the local IRB virtual MAC, so the frame is processed. The IRB L3 gateway determines the destination IP of server 1, and the associated destination network and VNI is examined. The lookup finds the MAC address of server 1 and selects the destination VTEP R5. The Layer 2 frame, where the original frame is modified, is encapsulated in a VXLAN packet. The original inner source MAC address is changed to be that of the IRB gateway. The outer header has a destination IP of the R5 VTEP and a VNI of 5200. This is the second tunnel. The packet arrives at the VTEP R5. The outer destination IP matches the VTEP address. The L2 gateway terminates the tunnel, and the frame is decapsulated. The destination MAC is found associated to GE002. The Layer 2 frame is sent to Server 1 with a destination MAC address of Server 1, a source MAC of IRB gateway R2 VTEP, a source IP of User 1, and a destination IP of Server 1. The VXLAN Layer 3 gateway functions of a centrally routed bridging or CRB scheme are explained here. When a frame must be routed or bridged to a different broadcast segment, the packet processing differs from a standard Layer 2 bridging function. With a VXLAN Layer 3 gateway, the gateway acts in a similar fashion to a standard Layer 3 gateway, with some differences. A VXLAN Layer 3 gateway is also a Layer 2 gateway, or VTEP. When a device in the network forwards a packet to an IP address that is part of a different subnet, the device forms an Ethernet frame with the destination MAC address of the locally configured default gateway, or the next hop in a routing table, also known as Routing Information Base or RIB. The source VTEP receives the frame and performs a MAC address lookup in the forwarding table. The Layer 3 gateway must be configured with an IRB interface within the source VNI so that the virtual MAC of the IRB is reachable by both the original host and the source VTEP.
The source VTEP encapsulates the original frame with the IP, User Datagram Protocol or UDP and VXLAN header information and forwards the frame through the VTEP tunnel that terminates on the Layer 3 gateway. Once the IP packet arrives at the gateway VTEP endpoint, the frame is processed as normal, with the IRB interface as the local host to which the original frame is destined. The Layer 3 gateway processes the Layer 2 frame normally and identifies the destination IP address in the inner packet. The Layer 3 gateway then performs another bridge table lookup to determine the physical next hop, VXLAN tunnel, that is associated with the destination IP address. Once the next hop is determined, the Ethernet frame sourced from the IRB virtual MAC address is forwarded over the next hop to the destination IP address. If the next hop towards the destination IP address is a VXLAN tunnel, the appropriate VXLAN IP, UDP, and VXLAN header information is placed on the packet prior to transmission.
Example shows the encapsulation information as a packet and a frame transit the VXLAN network toward a Layer 3 gateway. Host A sends a frame with its MAC address as the source and the L3GW MAC address as the destination. The source IP is 10.1.1.1 and the destination address is 10.2.1.1. Leaf 1 encapsulates the frame sent by host A and adds a VXLAN header with the Leaf 1 MAC as the source address and a spine MAC as the destination address. It also includes the Leaf 1 VTEP IP as the source and a spine VTEP as the destination. The spine is determined by the forwarding table. The spine receives the frame and decapsulates because its own VTEP address is the destination. The spine then passes the packet to the L3 gateway for a next hop lookup. Since the spine has an L3 gateway for both networks in the fabric, the spine resolves the MAC address for 10.2.1.1. The spine then encapsulates the packet, adds the new VNI for the new broadcast domain, uses the spine MAC address as the source address, the spine VTEP IP as the source IP, Leaf 3 as the destination MAC, and the Leaf 3 VTEP IP as the destination IP. When the frame arrives at Leaf 3, the packet is decapsulated, and Leaf 3 performs a bridge lookup and forwards the frame through the interface identified by the forwarding table. The location of Layer 3 gateways can have an impact on traffic processing and state information. There are three common locations to place the Layer 3 gateways. The two types of Layer 3 gateway placement are centrally routed bridging or CRB and edge-routed bridging or ERB deployment methods. The CRB method places the VNI transition points or Layer 3 gateways on the spine devices. With CRB deployments, Layer 3 gateway functions are centralized, and the spine devices depicted in the first of the examples shown are required to support VXLAN Layer 3 gateway capabilities and are VTEPs within the VXLAN domain. The second option, Fabric Layer 3 gateways, is also a centrally routed bridging deployment type. With the Fabric Layer 3 gateways, the spine devices of each data center pod or fabric branch are not required to have any VXLAN capabilities, as they only forward IP packets to and from leaf devices to the Layer 3 gateways within the fabric. The third option shown is an ERB deployment method. With an ERB deployment, bridging between broadcast domains, or IS, occurs on the leaf nodes at the edge of the network. Each of these designs has benefits and drawbacks. One benefit of CRB designs is the consolidation of Layer 3 gateway functions within subdomains. This enables the deployment of non-Layer 3 gateway-capable devices at the leaf nodes and provides modularity and scalability. One drawback of a centrally routed bridging design is a process called hairpinning. Hairpinning refers to the forwarding path of all traffic that must be forwarded between broadcast domains. Multiple broadcast domains can be connected to the same leaf device and even be present on the same host. Traffic that must be forwarded between those broadcast domains must be forwarded to the Layer 3 gateway device, wherever it is configured, and then returned to the destination host. The ERB design alleviates the hairpinning of traffic in the network by transitioning between broadcast domains on the leaf nodes themselves, which can then forward the transitioned frames to the remote VTEPs directly. The drawback to configuring ERB deployments is that the leaf nodes must support Layer 3 gateway functions, which can, at times, require a more advanced or expensive device at the leaf level. It also requires the configuration of gateway functions and addresses on each leaf within the deployment, which increases configuration and management overhead.